In this lecture, we will learn about some collision resolution strategies in hash table, okay? And in particular, we will look at open addressing scheme, okay? So what's this open addressing scheme? So in open addressing hashing system, all the data go inside the table itself. So last time we learned about the separate chaining or open hashing, in which we maintained linked list for each memory index, okay, and the hash table, and it grew in size, okay, it became more than the number of memory cells in hash table. But we will look at some other strategies where we don't utilize anything extra than the hash table memory itself, but this requires bigger table and it works when your load factor is below 0.5. Okay, so let's see what is there. So in open addressing, basically what happened in the open hashing, so whenever there was collision, okay, something collided here like 10, 20, 30, 40, 50 in case of a hash function, okay, where hx is x mod of 10. So this is, let's say, 0, index 0. So everything was, all these values will hash to index 0, and then we make a linked list like this. But the thing is, it requires some extra space, okay, in the linked list also needs memory, and I don't want that. I want that, okay, let's have open addressing, the all the memory values inside the hash table, all the memories that store all these, okay. So for that, what we do, so I will in fact give you one example, okay, one good example of what will happen here, okay. So the thing is, we have, let's say, the hash function h of x is x mod of 10. Again, the same example I'm taking. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So these many cells are there in your hash table, and I have the inputs, let's say 10, 20, 30, 40, 50. Now as you see, so all of them will be 10 mod of 10 is 0, 20 mod of 10 is 0, so on, everything will be mapping here, and they will be in the linked list like this: 50, 40, 30, 20 and 10. Okay, so this is a linked list, and this is the index 0 of your hash table. Okay, but the thing is, we have so many places in the hash table itself where memory is there free, but we are using some extra memory in this linked list. So we want that, okay, these memories should be utilized. Okay, so how to do that? And that's why we see that the concept of open addressing was there. Okay, so we want that these places that were there, I utilize these. I utilize, let's say that when I inserted 10, so 10 came here, somehow 20, I found that there was collision, then it should come here. Then again I find that, okay, h of 30, when I'm trying to find it, comes out to be 0. I want to insert it at 0, but it's already filled. Then what I do, I go to the next thing, next place, which is 1, h of 1, okay, place, okay, so ht hash table 1, this is also filled, so I go to the next place. So this is known as linear probing. Okay, we are basically probing. We found that, okay, h of 30 should belong to 0, it was already filled. I come to 2, basically next place, it was already filled. So h of 30, next thing what I can do is I can put it here. H of 40, again what I do, I search it here, it comes, it should be at 0, it's not empty. 20, next place, not empty. 30 is also not, next place of index 2 is not empty, I will put it here. So now you can see what will be our function here. So h of x will become basically hash of x plus f of I, okay, mod of 10. So now you will ask, what is this fi? So in this linear probing, so basically this f of I is nothing but I, okay. So hash, so this is hix. So first time I could not get some space, so I will now h of 0, okay. So h of 0 x will be hash of x plus f of 0, which is equal to 0 itself, and it will be mod of 10. So the first one will be hash of x mod of 10, so it will be the same. Others will be varying. Basically you add plus 1 plus 2 plus 3 to them till there are collisions is not resolved, okay. So we will see it formally. Let's see it here in the slides. So this is, we have cells h0x, h1x, h2x are tried in succession, where hix is given by hash of x plus fi modulo table size, okay, where f0 is 0. So hash x is there, which was x modulo 10, and then modulo table size, okay. So there are three common examples, okay, which are linear probing, quadratic probing, and double hashing. We will be using this one, linear probing. So what is linear probing? In linear probing, as we saw, collisions are resolved sequentially scanning an array with wraparound until an empty cell is found, okay. So this is what we were doing. We were just finding sequentially, okay, h of 20 we were putting at h of 20 is 0, but it was already occupied, so I moved to the next place. H of 30 is also 0, but 10, first place 0, second place 1 is occupied, I come to 30, and so on, okay. So f is a linear function, and typically we take f of I here is equal to I. That's what we were doing, okay. So when first time h of 20 collided, so f of 1 became 1, I did plus 1, so it moved to the next place. Now this example shows, okay, linear probing hash table after each insertion, okay. So let's see. So our hash, okay, so let's try to see. So this is the hix is hash of x plus fi mod table size, okay. So here we have, let's say, hash of x is x mod of 10, okay. This is hash of x. So first insertion is insert 89. 89 modulo 10, you get 9. I find that, okay, in this table hash table size is also 10, so 9 is free here, I put 89 here. Then we have to insert 18. 18 modulo 10 is 8. Cell number 8 is free, so I put 89 and 18 comes here. Then I need to put 49. 49 modulo 10 is 9. Now you see that, okay, so this 9 is now filled. Now what you do, h1 of 49 will be 49 modulo 10, 9 plus f of 1, which is fi is equal to I. So f of 1 will be 1, so it will be 9 plus 1 mod of table size 10, so 10 modulo 10, it's 0, so 49 comes here, okay. That's good, because now we are not going into a linked list, because so much free space is still there, okay. And then we have hash of 58. 58 will go to h of 0 will be, it will come to the 8th position. 58 modulo 10 is 8. It comes here, but again there is now collision. So what happens, h1 of 58 will be, so first one was, it was hash to 8 plus 1 modulo 10, 9 modulo 10, so again it finds a collision, okay. It will try hash 2, h258 is equal to 8 plus f of 2 is 2, 10 modulo 10, 0, Again it finds collision here also. Okay, so this two collisions it finds. So H3 it writes out for 58. So it's 8 plus 3 modulo 10, so it becomes 11 modulo 10 1. So now 58 comes to this place. Okay, and then what we try is 9, h of 9. Again 9 modulo 10 it tries to come here, it's not available. Then it tries plus 1, it comes here, not available. Plus 2, 9 plus 2 11 modulo 2. Okay, so then it comes here. Okay, so let's try. So this is what is happening. So now you see this is linear probing. So last one let's try to do again. So h of 9 will be 9. Okay, so that is filled. So h1 of 9 will be 9 plus 1 modulo 10. So 10 it becomes 0, it goes here. h2 of 9 will be 9 plus 2 11 modulo 10. 11 modulo 10 is again 1, it cannot go here. h3 of 9 is, so 9 plus 3, so 12 modulo 10, it goes to 2 and it finds its place here. Okay, so this is what is happening in linear probing. So we have different, for each of the steps we have different hi and we calculate like that. Now find and delete. Okay, so we have to search something. The find algorithm, this was the insertion we were talking about. The find algorithm follows the same probe sequence as the insertion algorithm. To find 58 would involve 4 probes. Okay, 58. When we try to find 58, so 58 let's try to do with some other color. So 58, h of 58 will be 8. I try to find it here, 58 is not there. Okay, in the last this table. Then I do h1 of 58, which is, so h hash of this value, so 8 plus 1, so 9 modulo 10. So it will try it here, not found. h2 58, it will be 8 plus 2 10 modulo 10 0, it doesn't find it here. h3 58, it's 8 plus 3 11 modulo 10 and it finds it at one place. So it requires 4. That's what it was saying. Involve 4 probes. 19 would involve 5 probes. Okay, so you can try out. So what is the problem here? Clustering problem. As long as a table is big enough, free cells you will always find, but the time to find so will become larger. Okay, this is called the clustering problem. We could see here also a lot of insertions. So we were this is the cluster that is formed. If you hit something here, you have to go all the way down. Okay, so that is something, the clustering problem. So for that, basically it tells that your lambda should be, that's why it was less than 0.5. Now linear probing, it just sees what is the average number of probes for a successful search and an unsuccessful search for this hash table. Okay, this has size 11. So if you need to find 20, so I will directly say that h of 20 is 20 modulo 11, which is 9. I find 20 here. H of 30 will be 30 modulo 11, so 8. I find 30 here, so it's just one hit directly. 2 modulo 11 is 2. I find 2 here. That's well done. And then let's see, we have 13. So 13 modulo 11 will be 2, but I don't find it here. So linear probing I do. I go further, plus 1, so it will be 13 plus 1, 14 modulo 2 modulo 11, it will become 3 and you will find it here. So 25 will require, now 25 modulo 11 will be 4 and it is found directly. Okay, so lot of things are happening. Okay, and it finds then that okay, average number of probes that is required is 15 by 8 for all these different cases. So it's nothing more than, less than in fact 2. Okay, so you are requiring 2 search for each one of them in this example. And similarly for unsuccessful search, how much you want. So if I'm searching, let's say 0, so those searches they are doing, so how much search you have to do. 0 is of course you can see not there, so h of 0 will be 0 mod of 11, so we will try to find it here. And then what you will do, you will try to find now h1 of 0, it will become 1 modulo 11, but it finds that it's empty, so it will stop, because then now there is no use. It means that there is no insertion. If you find an empty cell in the linear probing, you will stop. So for example, if I try to find 2, okay, and in fact 2 is there, so unsuccessful searches. Okay, 4, if I try to find 4, 4 modulo 11 is 4, I will try to search here, it's not found. I will increment by 1, 5 modulo 11, I will come here, I don't find it, and then increment again, empty cell found. So, okay, so you will not found. And then he finds that okay, unsuccessful search requires more comparisons because you have to find some empty cell. Okay, that's the problem here. So this is there, so it searches unsuccessful search. Next thing is quadratic probing, which will remove the problem of clustering, but this shows that okay, hash table in fact you can use the same memory, and it removes the problem of extra memory and extra data structure that was introduced in open hashing or separate chaining. So I hope you understand this. Thanks a lot.